Welcome to Grade 9 Math with Mr. Murphy. We are in Unit 3, Lesson 8, and we're learning how to substitute with substituting and solving. Our learning goals by the end of this class will be able to solve for a variable in a measurement and in other formulas. So let's begin. When substituting and solving. So formulas are often used to model linear relations, as seen in Unit 2, as well as measurement relations such as perimeter, area, and volume. You may have even seen some formulas in other classes, such as science class. We will use formulas to create equations by substituting in the values whose quantities are known. Then we will use our equation solving skills to solve for the missing variable. For example 1, we see a circumference equation that we know well. The circumference of a circle is given as 40.84 centimeters. What is the radius of the circle? Well, of course, this is the focus of this whole note, is that the thing that we're looking for is not already isolated. So the r is the thing we're looking for, but it is not isolated. So how are we going to do that? Well, we're going to use our skills of inverse operations, and we're going to reverse all the steps to get the r by itself. So let's think, if this was like we've done in the past, we'd say, well, what's happening to the r? Well, the r is being multiplied by a number called 2 pi. Now I say a number because pi is really a number. Pi is really 3.14, and it goes on and on and on. So pi represents a number. So anytime it's a variable, but it also is a number that we know. So we can just package that together and say that's what we have to remove from the r, and it's multiplied. So our inverse operation will just be one step. So let's do that rearrangement first, and then we will substitute for the c. So first things first, we will divide both sides by c, or by 2 pi. C equals 2 pi r. So like we said we would do, we're going to divide both sides by 2 pi. And that's what we said our step was, our inverse step. So we've done that now. So what does that do? Well, it cancels. That is the same number as that, so it cancels to 1. And so we can't do anything on this side. So c is still c over pi equals r. Of course, going back to our first information that they gave us, this is c. So let's put c in for that. So 40.84 divided by 2 pi equals r. All right. Well, I don't really want you to use just 3.14, so I really encourage you to use the pi button. So on most of your calculators, you can punch this in as one step. I would punch it in your calculator screen like this. And then I would bracket the 2 pi, because that bracket's going to make sure that the calculator reads it together. And sorry, that's a silly mistake. We're going to divide. So 40.84 divided by, and then I would press equal. Okay? And then your equal button. So if you put it all in one, and you have one of those calculators that has a large display, that will do it in one step for you. All right, so we get r equals 6.499999 Well, it's got a lot of large numbers. So um, in this case, well, we didn't indicate, but let's just do 1 decimal place and kind of round it to a nice number. And we are talking about centimeters. So therefore, the radius of this circle is 6.5 centimeters. All right, good. So that's an example where we had a formula that wasn't working for us because we needed R, which was not isolated. So we rearranged it to isolate the R, and then we started our substitutions, and then we solved it. And that's kind of the pattern we're going to look at today. So on our example 2, we have a common equation we know for triangles of area of the triangle. The area of the triangle has an area of 70 centimeters squared and a base of 14. What is the height? So we are looking for the height. But of course, the height is not isolated. So we have to inverse the operations. So again, what is happening to our h? The first thing that's happening is it's being multiplied by b. The second thing that's happening is it's being divided by 2. So our inverse operations are going to be times 2 and divided by b. So let's try that. So a equals bh over 2. And in our next step, we're going to do the multiplication. bh over 2. This is our a, of course. And again, anytime we can, we reduce early. We cancel out things early. 2 times a gives us 2a. And then we're left with the bh here. So we did our first step. What's the next step? Well, divide by b. And so we get, this awkward kind of equation on this side. Doesn't seem to mean much, but it's now isolated for h, which is perfect. That's what we want to do. So we'll bring this up here, and we'll solve for h now. Now, sometimes I like to work left to right, and there's nothing that changes. If I just switch that h over there, I'm just switching places. It doesn't change anything. So I have 2 times, now what was a? So a we're going to bring from up here. Okay. And so a was 70. And b we're bringing in from over here. And that was 14. So we're going to get 2 times 70. You could probably do that in your head. 140. And look how nice these numbers are working out. So you know that that will go into it 10 times. So h equals 10. So therefore, the height is 10 centimeters. All right, so again, another example where we have a very well-known equation, usually used for area, but we were able to rearrange it to isolate for the h. Example 3. Well, get back to 3. I want you to pause the video, and I want you to try this one by yourself. We'll read it together first. So the perimeter of the rectangle is 63. If the width of the garden is 11, and what is the length? So can you rearrange this to isolate? That's really what we're doing. We're isolating a different variable, the L. So pause the video and try this, and I'll join back in a minute or seconds, a few seconds. All right, so let's try this out. Okay, I'm not really going to wait a minute for you. So you have to pause that. I'd like you to try those questions sometimes before I just give you the answers. So we are trying to isolate L. So what are the things that are happening to L? Well, L is being multiplied by 2. Then it's being added by 2W. So we can package that together. We don't need to do more splitting up of those. So then our inverse operations are to subtract 2W and divide by 2. All right, so our first step would be 2L plus 2W. The first thing we want to do is subtract 2W from both sides. So what are we going to be left with? Well, these are going to cancel. So we have P minus 2W equals 2L. All right, that step is done. Next, we want to divide by 2 on both sides. All right, so, we'll cancel those 2's. We have length will equal P minus 2W over 2. Okay, well, let's substitute then. We're going to sub P equals 63. And sometimes I like to write this out. I find it helps with communication of the problem. And our width is 11. Okay, so let's fill those in. So again, maybe we'll put L on the left side now. And so we have, for P, we have 63 and minus 2, and W is 11. And it's all divided by 2. So length is 63. Well, what's 2 times 11 is 22 over 2. And then length is 41 over 2. So length is 20.5 meters. And again, you can have a therefore statement, in a nice sentence after that. Good. So I hope you were able to try that and then have success with it. All right, good. Let's keep going. Sometimes, instead of substituting a number, we may need to substitute a different algebraic term or expression for one of the variables in the problem. Then there are so many like terms to gather before using inverse operations to solve. So that seems like a lot to understand. So let's get into an example. It might help. Sam makes rectangular paving stones that are 10 centimeters long. Then they are wide. So we have an expression. If one is wide as W, then one is wide. The length is wide plus 10. If the perimeter of stones is 60 centimeters, calculate the dimensions of the stone. Okay, so basically its translation is isolate W. We're going to want to isolate W. All right, well, how are we going to do that? So we have to decide one of them has to be length, one of them has to be width. Well, just go by the pictures. This is our width. This is likely our length. Okay, now notice we have 2 of them. We have 2 lengths, 2 widths. Okay, so now we can, it is difficult to isolate everything, but why don't we try one where we just substitute right in, because I know some of you are going to want to rely on doing that instead of doing all the isolations. So let's do this. So, well, P equals 60. Length is W plus 10, and width is just called W. So that's sort of our given information. That's good to know. Okay, so if we're going to solve this now, so P equals 2L plus 2W. Let's substitute in the numbers. So we have 60 equals 2 times L. Now L is W plus 10 plus 2, and hardly makes sense to substitute this, but there it is, W for a W. So guess what we're going to have to use? We're going to have to use our distributive property. So I'm going to try now. You're going to pause it, pause the video, try to solve this on your own, and I'll come back to help you out. All right, so let's try continuing here. We're going to distribute in 2 steps here. So nothing's changed. We have 60 on this side, but 2 times W is 2W. 2 times 10 is 20, and plus 2W. So now you notice we have some like terms. And just like we've been practicing. So now it's like any other question. So if we can get all this stuff sorted out, this early stuff, then the rest of it just becomes an easy problem. And that's what I want you to think about. Like, people get nervous about word problems, but if you can do the figure out the key information, then when it just comes down to the math, you're all going to do just fine. Okay. So we're going to bring the 20 over, change its sign, obviously. And so we have 60 minus 20 equals, now it's gone now, so we have 2W plus 2W. So 60 minus 20 is 40, and 2 plus 2 is 4 W's. So we're going to divide both sides by 4, and we get W equals 10. So that's perfect. So now that that gives us the basis of what W is, but it says calculate the dimensions, all of them. So, we have to do all of them. So we would say we'd come back to this stuff. And we'd say, okay, well, W is equal to W. So W equals 10. I know it sounds pretty redundant to say all that, but that's what we're going to do. And then we're going to say, well, length is not W. Length is W plus 10. So length is 10 plus 10, because length W is the W. W is 10. So length is 20. And so I haven't left myself a lot of room for a therefore statement, but you'd want to say something like, therefore, the width is 10 and the length, well, ... You get it. You get the point. The length is 20 centimeters. Okay, very good. So moving right along, we've got quite a few examples. So, well, 2 more examples. The next one, we are looking at a triangle. The sail of a boat is in the shape of a triangle. Alan designs a sail in the shape of a triangle. The area of the sail is 18 meters squared. So area is always a squared number. The base and height are equal. That's important to know. And determine the height of this sail. All right. So Well, if we know that the base and the height are the same, we could give them the same measurement. So here's my suggestion. That the base we're going to call x, and the height we're going to call x. And so if we substituted this in, okay, we could say a equals base times height divided by 2. Well, if those are x's, right, sub b equals x and h equals x, so we have x times x divided by 2. Well, x times x, we learned really early on in this unit that that was x squared divided by 2. Now we need to get the x's on their own. So your choice, whether you want to substitute right in or isolate the x. So we could isolate the x. We could do, well, what's happening here? It's being divided, right? The x squared is being divided. So the first thing I want to do is maybe multiply both sides by 2. Well, that's going to eliminate and eliminate. And then what are we left on this side? So 2a and x squared. Good. Now, how do we get rid of an x squared? Well, we need to square root it. Square root it. So we have x equals square root of 2a. Can't do anything about it right now. So what can we finally do? So now we can substitute. We're going to sub a equals 18. So x equals the square root of 2 times 18. Well, you might know you're thinking ahead already, and you're going, oh, this is going to work out good because 2 times 18 is 36, and that's a perfect square, and the square root of 36 is 6. Now, looking back at our question, that was in meters. So therefore, the height of the sail, okay, I didn't write the sail, the height of the sail is 6 meters. Very good. Okay. Moving along. Okay, finally, you will need to remember your equation creating skills from the last unit to create equations that model linear relations. Remember the rate of change and initial value. Frances earns $426 this week. She is paid $11.25 per hour and got a bonus of $50 this week for completing a project early. How many hours did she work this week? Okay, so we have to come up with like a model equation of what this might look like. So you might say, okay, so what can we say her earnings? Maybe her earnings are E. So let E be earnings. What else is in here? So she has her earnings, and she has a rate. So, well, we called that slope before, so we could call it slope or a rate. So let M be rate of pay per hour. Okay, well, she would need to know how many hours she worked. So you could use H. Let H be hours worked. Okay, so that's how much hours she's working. H be the hours. And we had a bonus. So hey, why not use B? Let B be the bonus. So let's see. So her earnings would be the rate and her hours together because you get paid per hour. So that's a rate. So that would sort of be M and H together, right? And the earnings. So her total would be something like this. Like her earnings would be the rate plus how much hours she works, or not plus, multiplied by how many hours. But then there's this bonus, and the bonus, it doesn't say anything about the bonus like being tied to hours or anything like that. So I think the bonus is on its own. To be honest, I think it's all by itself. So think about that because it's not really tied to anything, right? And she's really getting her earnings per week. So it's not like we're bonuses per week or anything like that. They don't tell us anything more than that. So I like this equation. So I want you to pause the video and try to solve it from this point on. Okay, go. All right, we're back. You've solved it. We're going to see if you're right. All right, so we are going to substitute these numbers. So we said that E was 426. We said that M was her rate of pay, 1125. We said her hours. We don't need to make a bracket. We just don't know what hours are. So that's actually what we're looking for, is the hours, right? That's our hours. We're looking for the hours. And our bonus was the $50 to start with. So the 426, like that's a total that includes that bonus. So we have to peel that $50 away from what they earned for the week to find out really get down to the hourly wage. So that cancels. 426 minus 50 is 376, and then 11.25 hours. And so we are going to divide, we want to get the H by itself. So these are multiplied, so we must divide them. Okay. And then obviously we like our little yellow cancel effect. And well, you're not going to do this one in your head. So put that in a calculator and you get 33.4. 33.4. So awesome. All right. So therefore, what was her name again? Frances worked 33.4 hours that week. And there we go. That's the last of your examples. So what I want you to do going forward is try to practice these sheets. There's quite a few of them there. Okay. And we can take up some of these questions during our get-togethers for our video meets. And again, some of you want more challenge, so you can go on to Mathletics and look at those exercises. And that's just one more option that you have to practice. All right, so take care, and we'll see you soon.